Bueno, creo que hay menos ruido, a ver, no sé, si no se no incrementa el ruido. Hoy les contaba que quería, quiero, mejor dicho, hablarles sobre un tema actual que tiene que ver con la inteligencia artificial. Es un tema que lo debemos de conocer porque nos va a afectar a todos. ¿Qué es la inteligencia artificial o la IA? La inteligencia artificial, por decirlas IA, es un conjunto de tecnologías que permiten que las computadoras realicen una variedad de funciones avanzadas, incluidas la capacidad de comprender, hacer recomendaciones sin información. La inteligencia artificial es la columna vertebral de la innovación en la comunicación moderna, lo que genera valor para las personas. Sí, disculpe. Decía que la inteligencia artificial es la columna vertebral de la innovación en la computación moderna, lo que genera valor para las personas y las empresas. Por ejemplo, el reconocimiento óptico de caracteres usa la inteligencia artificial para extraer textos, datos, imágenes, documentos y convierte el contenido no estructurado en datos estructurados listos para las empresas, además de brindar estadísticas valiosas. La pregunta surge, ¿todo listo para comenzar? Los clientes nuevos obtienen $300 en créditos gratuitos que pueden usar en Google Cloud o Cloud, nube. La definición de inteligencia artificial es un campo de ciencia relacionado con la creación de computadoras y máquinas que pueden razonar, aprender y actuar de una manera que normalmente requeriría inteligencia humana o que involucra datos cuya escala excede lo que son los humanos o los humanos que pueden analizar. La inteligencia artificial es un campo amplio que incluye muchas disciplinas como la información, el análisis, la estadística de datos, la ingeniería de hardware, software, la lingüística, la neurociencia y hasta la filosofía y la psicología. A nivel operativo, para el uso empresarial, la inteligencia artificial es un conjunto de tecnologías que se basan principalmente en el aprendizaje automático y el aprendizaje profundo que se usan para el análisis de datos, la generación de predicciones y previsiones, la categorización de objetos, el procedimiento de lenguaje natural, las recomendaciones y las recuperaciones inteligentes de datos y mucho más. Como pregunta, ¿cómo funciona la inteligencia artificial? Si bien los detalles varían según las diferentes técnicas de la inteligencia artificial, artificial, el principio central gira en torno a los datos. Sistemas de inteligencia artificial aprenden y mejoran a través de exposiciones y grandes cantidades de datos, lo que permite identificar patrones y relaciones que las personas pueden pasar por alto. Este proceso de aprendizaje suele implicar algoritmos que son conjunto de reglas o instrucciones que guían el análisis y la toma de decisiones de la inteligencia artificial. En el aprendizaje automático, un subconjunto popular de la inteligencia artificial, los algoritmos se entrenan con datos equipados o no etiquetados para hacer predicciones o categorizar información. El aprendizaje profundo, una especialización adicional que utiliza redes neuronales artificiales con varias capas para procesar información, imitando la estructura y la función del cerebro humano a través del aprendizaje y la adaptación continuos. Los sistemas de inteligencia artificial se mueven cada vez más hábiles en la realización de tareas específicas, en el reconocimiento de imágenes hasta la traducción de idiomas y más. ¿Quieres aprender a usar la inteligencia artificial? Realiza el curso para principiantes gratuito. ¿Qué es interesante? ¿Cómo? Por ejemplo, un principiante, esto es solo que no sé si le puede hacer una traducción, pero es interesante aprender esto. Introducción, está todo en inglés, y la traducción tendría que tomar mucho tiempo, pero sí, en internet puede hacer el curso gratuito de el inicio de inteligencia artificial, curso de 1 hora, 45 minutos. Muy interesante está este tema. No hay que menospreciarlo, hay que investigarlo, porque hay mucho que aprender al respecto. Vamos a volver al tema. Hay varios tipos de inteligencia artificial. Existe, número uno, la máquina reactiva. Número dos, la memoria limitada. Número tres, teoría de la mente. Y la cuarta, autoconocimiento. Modelos de entrenamiento de inteligencia artificial. Cuando las empresas hablan de inteligencia artificial, suelen hablar de datos de entrenamiento, pero ¿qué significa eso? Recuerde que la inteligencia artificial con memoria limitada es una inteligencia que mejora el tiempo. Tipos comunes de redes neuronales artificiales. Beneficios de la inteligencia artificial, esto está bien. La automatización, la inteligencia artificial puede automatizarse flujos de trabajo y procesos de trabajo de forma independiente y automática de un equipo humano. Por ejemplo, puede ayudar a automatizar aspectos de la ciberseguridad a través de la supervisión y el análisis continuo del tráfico de red. De manera similar, una fábrica inteligente puede tener decenas de tipos de diferentes inteligencias artificiales en uso, como robots que usan visión artificial para navegar en las fábricas o inspeccionar productos en busca de defectos, crear gemelos digitales o usar análisis o usar analítico en tiempo real para medir la eficiencia de la traducción. Rápido y preciso, la inteligencia artificial puede procesar más información con más rapidez que un ser humano mediante la búsqueda de patrones y el descubrimiento relacionados en datos en humanos que el humano no podría. Este tema está interesante y está profundo. Usted lo puede investigar más en la red, pero tiene que ir y buscar inteligencia artificial. Aquí hay una explicación más o menos sobre esto. Se la voy a, no sé si está en inglés, creo que sí está en inglés, pero mucha gente ya habla y entiende el inglés.
Hi, and welcome to Introduction to Generative AI. Don't know what that is? Then you're in the perfect place. I'm Roger Martinez, and I am a Developer Relations Engineer at Google Cloud, and it's my job to help developers learn to use Google Cloud. In this course, I'll teach you 4 things: how to define generative AI, explain how generative AI works, describe generative AI model types, describe generative AI applications. But let's not get swept away with all of that yet. Let's start by defining what generative AI is first. Generative AI has become a buzzword, but what is it? Generative AI is a type of artificial intelligence technology that can produce various types of content, including text, imagery, audio, and synthetic data. But what is artificial intelligence? Since we are going to explore generative artificial intelligence, let's provide a bit of context. 2 very common questions asked are, what is artificial intelligence and what is the difference between AI and machine learning? Let's get into it. So one way to think about it is that AI is a discipline, like how physics is a discipline of science. AI is a branch of computer science that deals with the creation of intelligent agents and are systems that can reason, learn, and act autonomously. Are you with me so far? Essentially, AI has to do with the theory and methods to build machines that think and act like humans. Pretty simple, right? Now let's talk about machine learning. Machine learning is a subfield of AI. It is a program or system that trains a model from input data. The trained model can make useful predictions from new, never before seen data drawn from the same one used to train the model. This means that machine learning gives the computer the ability to learn without explicit programming. So what do these machine learning models look like? 2 of the most common classes of machine learning models are unsupervised and supervised ML models. The key difference between the 2 is that with supervised models, we have labels. Labeled data is data that comes with a tag, like a name, a type, or a number. Unlabeled data is data that comes with no tag. So what can you do with supervised and unsupervised models? This graph is an example of the sort of problem a supervised model might try to solve. For example, let's say you're the owner of a restaurant. What type of food do they serve? Let's say pizza or dumplings. No, let's say pizza. I like pizza. Anyway, you have historical data of the bill amount and how much different people tipped based on the order type, pickup or delivery. In supervised learning, the model learns from past examples to predict future values. Here, the model uses the total bill amount data to predict the future tip amount, based on whether an order was picked up or delivered. Also, people, tip your delivery drivers. They work really hard. This is an example of the sort of problem that an unsupervised model might try to solve. Here, you want to look at tenure and income, and then group or cluster employees to see whether someone is on the fast track. Nice work, Blue Shirt. Unsupervised problems are all about discovery, about looking at the raw data and seeing if it naturally falls into groups. This is a good start, but let's go a little deeper to show this difference graphically, because understanding these concepts is the foundation for your understanding of generative AI. In supervised learning, testing data values, X, are input into the model. The model outputs a prediction and compares it to the training data used to train the model. If the predicted test data values and actual training data values are far apart, that is called error. The model tries to reduce this error until the predicted and actual values are closer together. This is a classic optimization problem. So let's check in. So far, we've explored differences between artificial intelligence and machine learning, and supervised and unsupervised learning. That's a good start. But what's next? Let's briefly explore where deep learning fits as a subset of machine learning methods. And then I promise we'll start talking about Gen AI. While machine learning is a broad field that encompasses many different techniques, deep learning is a type of machine learning that uses artificial neural networks, allowing them to process more complex patterns than machine learning. Artificial neural networks are inspired by the human brain. Pretty cool, huh? Like your brain, they are made up of many interconnected nodes, or neurons, that can learn to perform tasks by processing data and making predictions. Deep learning models typically have many layers of neurons, which allows them to learn more complex patterns than traditional machine learning models. Neural networks can use both labeled and unlabeled data. This is called semi-supervised learning. In semi-supervised learning, a neural network is trained on a small amount of labeled data and a large amount of unlabeled data. The labeled data helps the neural network to learn the basic concepts of the tasks, while the unlabeled data helps the neural network to generalize to new examples. Now we finally get to where generative AI fits into this AI discipline. Gen AI is a subset of deep learning, which means it uses artificial neural networks, can process both labeled and unlabeled data using supervised, unsupervised, and semi-supervised methods. Large language models are also a subset of deep learning. See, I told you I'd bring it all back to Gen AI. Good job, me. Deep learning models, or machine learning models in general, can be divided into two types: generative and discriminative. A discriminative model is a type of model that is used to classify or predict labels for data points. Discriminative models are typically trained on a data set of labeled data points, and they learn the relationship between the features of the data points and the labels. Once a discriminative model is trained, it can be used to predict the label for new data points. A generative model generates new data instances based on a learned probability distribution of existing data. Generative models generate new content. Take this example. Here, the discriminative model learns the conditional probability distribution, or the probability of y, our output, given x, our input, that this is a dog, and classifies it as a dog, and not a cat, which is great because I'm allergic to cats. The generative model learns the joint probability distribution, or the probability of x and y, p of x, y, and predicts the conditional probability that this is a dog, and can then generate a picture of a dog. Good boy. I'm going to name him Fred. To summarize, generative models can generate new data instances, and discriminative models discriminate between different kinds of data instances. One more quick example. The top image shows a traditional machine learning model which attempts to learn the relationship between the data and the label, or what you want to predict. The bottom image shows a generative AI model which attempts to learn patterns on content so that it can generate new content. So, what if someone challenges you to a game of, is it Gen AI or not? I've got your back. This illustration shows a good way to distinguish between what is Gen AI and what is not. It is not Gen AI when the output, or Y, or label, is a number or a class. For example, spam or not spam, or a probability. It is Gen AI when the output is natural language, like speech or text, audio, or an image like Fred from before, for example. Let's get a little mathy to really show the difference. Visualizing this mathematically would look like this. If you haven't seen this for a while, the y equals f of x equation calculates the dependent output of a process given different inputs. The y stands for the model output, the f embodies the function used in the calculation or model, and the x represents the input or inputs used for the formula. As a reminder, inputs are the data like comma-separated value files, text files, audio files, or image files like Fred. So the model output is a function of all the inputs. If the y is a number like predicted sales, it is not generative AI. If y is a sentence like define sales, it is generative, as the question would elicit a text response. The response will be based on all the massive large data the model was already trained on. So, the traditional ML supervised learning process takes training code and labeled data to build a model. Depending on the use case or problem, the model can give you a prediction, classify something, or cluster something. Now, let's check out how much more robust the generative AI process is in comparison. The generative AI process can take training code, labeled data, and unlabeled data of all data types and build a foundation model. The foundation model can then generate new content. It can generate text, code, images, audio, video, and more. We've come a long way from traditional programming to neural networks to generative models. In traditional programming, we used to have to hard code the rules for distinguishing a cat. Type, animal, legs, 4, ears, 2, fur, yes, likes, yarn, catnip, dislikes, Fred. In the wave of neural networks, we could give the networks pictures of cats and dogs and ask, is this a cat? And it would predict a cat or not a cat. What's really cool is that in the generative wave, we as users can generate our own content, whether it be text, images, audio, video, or more. For example, models like Gemini, Google's multimodal AI model, or Lambda, language model for dialogue applications, ingest very, very large data from multiple sources across the internet and build foundation language models we can use simply by asking a question, whether typing it into a prompt or verbally talking into the prompt itself. So, when you ask it, what's a cat, it can give you everything it's learned about a cat. Now, let's make things a little more formal with an official definition. What is generative AI? Gen AI is a type of artificial intelligence that creates new content based on what it has learned from existing content. The process of learning from existing content is called training and results in the creation of a statistical model. When given a prompt, Gen AI uses a statistical model to predict what an expected response might be, and this generates new content. It learns the underlying structure of the data and can then generate new samples that are similar to the data it was trained on. Like I mentioned earlier, a generative language model can take what it has learned from the examples it's been shown and create something entirely new based on that information. That's why we use the word generative. But large language models, which generate novel combinations of text in the form of natural sounding language, are only one type of generative AI. A generative image model takes an image as input and can output text, another image, or video. For example, under the output text, you can get visual question and answering, while under output image, an image completion is generated, and under output video, animation is generated. A generative language model takes text as input and can output more text, an image, audio, or decisions. For example, under the output text, question and answering is generated, and under output image, a video is generated. I mentioned that generative language models learn about patterns in language through training data. Check out this example. Based on things learned from its training data, it offers predictions of how to complete this sentence. I'm making a sandwich with peanut butter and jelly. Pretty simple, right? So, given some text, it can predict what comes next. Thus, generative language models are pattern matching systems. They learn about patterns based on the data that you provide. Here is the same example using Gemini, which is trained on a massive amount of text data and is able to communicate and generate human-like text in response to a wide range of prompts and questions.